My dear students, welcome back to our channel. Students, in this video I am explaining MBA third semester. Subject Total Quality Management, second unit. Important long question answers. Let's start quick revision. First important long question is: discuss about the tools histograms, run charts, scatter diagrams and their applications in TQM. In Total Quality Management, TQM, tools like histograms, run charts and scatter diagrams are vital for understanding processes, identifying problems and driving improvements. Histograms. A histogram is a bar graph that represents the frequency distribution of data. It helps in visualizing the variation in a process, highlighting patterns such as skewness, clustering, or outliers. In TQM, histograms are used to analyze data distributions, measure process stability, and identify areas that need improvement. For example, a histogram can reveal whether the defects in a manufacturing process are random or systematic, thus guiding corrective actions. Run charts. A run chart displays data points in a time sequence, enabling the observation of trends, patterns, or shifts over time. It is a simple but powerful tool to monitor the performance of a process. In TQM, run charts are essential for tracking improvements and detecting anomalies early. For example, if a production line's defect rate fluctuates unexpectedly, a run chart can highlight when the process deviated from its normal performance, allowing teams to investigate the cause and take corrective actions promptly. Scatter diagrams. A scatter diagram, also known as a scatter plot, depicts the relationship between two variables. Each point represents a pair of values. In TQM, scatter diagrams are used to identify correlations between process variables, which can uncover root causes of issues. For instance, a scatter diagram could reveal a relationship between machine temperature and defect rates, guiding interventions like adjusting machine settings or implementing preventive maintenance. Applications in TQM. In TQM, these tools play a crucial role in data-driven decision-making. Histograms help in understanding process variation, run charts monitor ongoing performance, and scatter diagrams uncover potential causes of defects or inefficiencies. By utilizing these tools, organizations can focus on continuous improvement, reduce variability, and enhance product quality. They allow for proactive problem solving and provide valuable insights into both process stability and opportunities for optimization. In conclusion, these tools form the backbone of quality improvement initiatives in TQM, enabling businesses to measure, analyze, and refine their processes to achieve consistent quality outcomes. Next important long question is: explain process mapping and regression analysis in TQM. In Total Quality Management, TQM, process mapping and regression analysis are crucial tools used for improving quality and optimizing operations. These tools help in understanding processes, identifying bottlenecks, and making data-driven decisions. Process mapping. Process mapping is a visual representation of the steps involved in a process. It allows organizations to document and analyze workflows, identifying each task, decision point, and the flow of materials or information. In TQM, process mapping is used to highlight inefficiencies, redundancies, and non-value-adding activities, thereby allowing businesses to streamline processes. It helps in standardizing operations, improving communication among teams, and ensuring that all steps contribute to the final goal. For example, in a manufacturing process, a flowchart can be created to illustrate each stage from raw material to finished product. By mapping the process, an organization can identify delays, excessive handoffs, or areas prone to defects, leading to targeted improvements such as process reengineering, automation, or better employee training. Regression analysis. Regression analysis is a statistical method used to examine the relationship between one dependent variable and one or more independent variables. In TQM, regression analysis helps in understanding how different factors influence a process outcome, enabling organizations to identify key drivers of performance. By analyzing this relationship, businesses can predict outcomes, control variability, and improve decision-making. For example, regression analysis might be used in a production environment to analyze how factors such as machine speed, temperature, and humidity affect product quality. Understanding these relationships allows for better control of the production process, helping reduce defects and enhance consistency. Applications in TQM. Both process mapping and regression analysis are essential for achieving continuous improvement in TQM. Process mapping provides a clear understanding of how processes work and where improvements are needed, while regression analysis quantifies relationships between variables, helping in predicting and optimizing outcomes. Together, these tools empower organizations to enhance efficiency, reduce waste, and improve quality consistently. In conclusion, process mapping and regression analysis are vital for diagnosing issues, optimizing processes, and supporting data-driven decisions in TQM, ultimately contributing to better quality management and organizational success. Next important long question is: explain various tools used for measuring TQM. In total quality management, TQM, various tools are used to measure, analyze, and improve processes, ensuring that organizations consistently deliver high quality products and services. These tools help in identifying issues, monitoring performance, and driving continuous improvement. 1. Pareto analysis. The Pareto principle, or the 80-20 rule, suggests that 80% of problems stem from 20% of causes. Pareto analysis helps prioritize which problems to address first by identifying the most significant issues based on their frequency or impact. It is often visualized in a bar chart that ranks causes in descending order of importance, allowing organizations to focus on the critical few that will yield the greatest improvement. 2. Control charts. Control charts are used to monitor process performance over time. They display data points in a time sequence and highlight upper and lower control limits. By comparing actual data to these limits, organizations can detect variations in a process, distinguishing between common cause variations inherent to the process and special cause variations due to external factors. This tool helps in maintaining process stability and identifying the need for corrective actions. 3. Histograms. A histogram is a graphical representation of the distribution of data. It helps in understanding the spread, shape, and central tendency of a dataset, providing insight into the level of variability within a process. By visualizing data patterns, histograms aid in identifying areas that may require improvement or standardization. 4. Scatter diagrams. Scatter diagrams plot the relationship between two variables to identify correlations. In TQM, they are used to analyze how changes in one factor, example, machine speed, influence another, example, defect rate. This tool helps identify possible root causes of problems, enabling more targeted interventions. 5. Fishbone diagram, Ishikawa. The fishbone diagram is a cause and effect tool used to identify potential root causes of a problem. It categorizes causes into major groups like people, processes, equipment, materials, environment, and management, allowing teams to explore all possible factors contributing to a quality issue. 6. Surveys and customer feedback. Customer satisfaction surveys and feedback mechanisms are critical tools for measuring quality from the customer's perspective. By gathering insights on customer experiences, businesses can identify areas of improvement and ensure their products or services meet customer expectations. Conclusion. These tools, Pareto analysis, control charts, histograms, scatter diagrams, fishbone diagrams, and customer feedback, are foundational to measuring and improving quality in TQM. They allow organizations to monitor performance, identify root causes of problems, and focus efforts on the most impactful areas. By leveraging these tools, businesses can ensure continuous improvement and maintain high-quality standards, ultimately leading to greater customer satisfaction and operational efficiency. Next important long question is: explain the objectives and benefits of the quality circles. Quality circles are small, voluntary groups of employees who meet regularly to discuss and solve work-related problems, particularly those affecting quality. These circles focus on improving processes, increasing productivity, and fostering collaboration. The concept originated in Japan in the 1960s and has since been adopted by many organizations worldwide as a key component of total quality management, TQM. Objectives of quality circles. 1. Problem identification and solution. The primary objective of a quality circle is to identify problems within the workplace, especially those that affect the quality of products or services, and to find practical, cost-effective solutions. 2. Employee involvement. Quality circles aim to engage employees at all levels in decision-making and problem-solving processes, fostering a sense of ownership and accountability. 3. Continuous improvement. They focus on incremental improvements, enabling small yet significant enhancements in process efficiency, quality, and productivity over time. 4. Skill development. Quality circles provide a platform for employees to develop problem-solving, teamwork, and leadership skills, which benefit both individuals and the organization as a whole. 5. Promote teamwork. They encourage collaboration across different levels of the organization, breaking down silos and promoting a culture of collective responsibility. Benefits of quality circles. 1. Improved quality. By involving employees directly in identifying and solving quality issues, quality circles contribute to higher product quality and service excellence. 2. Enhanced employee morale. Employees feel valued and empowered when they are actively involved in decision-making, leading to improved job satisfaction and morale. 3. Cost reduction. Quality circles often identify inefficiencies or waste within processes, leading to cost savings through process improvements and reduced defects. 4. Increased productivity, continuous improvements fostered by quality circles help streamline workflows and eliminate bottlenecks, which can lead to increased productivity. 5. Better communication, regular interaction within quality circles enhances communication between workers, management, and other departments, fostering a more transparent and cooperative organizational culture. 6. Faster problem resolution. Empowered employees can quickly address and resolve issues, minimizing downtime and disruptions to operations. Conclusion. Quality circles offer a structured yet flexible approach to solving problems and improving quality within an organization. By involving employees in the process, they foster a culture of collaboration, accountability, and continuous improvement. The objectives of quality circles, problem-solving, skill development, and teamwork translate into significant benefits, including better product quality, cost savings, increased employee satisfaction, and improved productivity. Ultimately, quality circles contribute to the success of TQM by encouraging an engaged workforce and a proactive approach to process enhancement. Next important long question is: explain the components of 5 Whys and 5 S's tools of TQM. The 5 Whys and 5 S are 2 essential tools in total quality management (TQM), aimed at identifying root causes of issues and improving workplace organization and efficiency. Each tool has distinct components that contribute to problem solving and continuous improvement. 5 Whys. The 5 Whys is a simple yet effective technique used to explore the root cause of a problem by asking why multiple times, typically 5. The idea is that asking why repeatedly helps peel away the layers of symptoms to identify the underlying cause. Components of 5 Whys. 1. Problem identification. Start by clearly defining the problem. This ensures that the team is addressing the correct issue. 2. Asking why. After identifying the problem, the first why is asked to understand why it occurred. The answer leads to the next question. 3. Repeat the process. Each successive answer to a why forms the basis for the next question. This is done until the root cause is identified. Typically after 5 iterations, though it can take fewer or more. 4. Root cause identification. The goal is to uncover the fundamental issue rather than just addressing superficial symptoms. 5. Corrective action. Once the root cause is identified, corrective actions are implemented to prevent recurrence. Example. Problem: the machine stopped working. 1 Why? The motor overheated. 2 Why? The cooling system failed. 3 Why? The cooling fan was clogged. 4 Why? The fan wasn't cleaned regularly. 5 Why? There was no maintenance schedule. 5S. The 5S is a workplace organization tool designed to create and maintain an efficient, clean, and safe working environment. It involves 5 steps that help eliminate waste and ensure that processes run smoothly. Components of 5S. 1. Sort. Seri: eliminate unnecessary items from the workplace. Keep only what is essential to avoid clutter and distractions. 2. Set in order. Seat on organized tools, materials, and equipment in a way that ensures they are easy to find and use, improving efficiency. 3. Shine. Say so, keep the workplace clean and tidy. Regular cleaning helps maintain equipment and fosters a safe and pleasant work environment. 4. Standardize. Seiketsu develop standardized procedures for performing tasks, ensuring consistency and preventing errors. 5. Sustain. Shitsuke foster a culture of discipline to ensure that the 5S principles are consistently applied and maintained over time. Conclusion. The 5 Whys and 5S tools are integral to the TQM framework, focusing on problem solving and process efficiency. The 5 Whys helps identify and address the root causes of issues, while the 5S focuses on creating an organized and efficient workplace. Together, they improve quality, reduce waste, and ensure continuous improvement by promoting better processes, employee involvement, and organizational discipline. These tools are fundamental for achieving sustainable quality improvement and operational excellence. Next important long question is: explain the Kazin and JIT tools of TQM. Kazin and Just-in-Time JIT are two critical tools in total quality management TQM that focus on continuous improvement and process efficiency. Both methodologies contribute to reducing waste, enhancing productivity, and improving quality in organizational processes. Kazin. Kazin is a Japanese term meaning continuous improvement. It refers to a philosophy of making small, incremental improvements over time rather than implementing large, radical changes. In TQM, Kazin emphasizes involving all employees in identifying areas for improvement and making small, consistent changes to improve processes. Components of Kazin. 1. Continuous improvement. The core of Kazin is the idea that every process, no matter how well it is functioning, can always be improved. It focuses on making small, manageable changes rather than large-scale disruptive overhauls. 2. Employee involvement. Kazin encourages participation from employees at all levels. Workers are seen as key contributors to problem identification and solution generation. 3. Waste elimination. By continuously evaluating processes, Kazin seeks to eliminate waste in time, materials, labor, etc., and inefficiencies. 4. Standardization. After improvements are made, the new processes are standardized and documented, ensuring that the improvements are maintained and replicated. Benefits of Kazin. Encourages innovation and creativity at all levels. Fosters a culture of collaboration and teamwork. Leads to significant long-term improvements with minimal disruption. Just-in-Time JIT. Just-in-Time JIT is a production strategy that focuses on minimizing inventory and producing goods only when needed. JIT seeks to streamline production by reducing waste, improving efficiency, and ensuring that products are made in exactly the right quantities at the right time. Components of JIT. 1. Demand-driven production. Products are manufactured only when there is a direct demand or order, which helps avoid overproduction and excess inventory. 2. Minimizing inventory. JIT minimizes stock levels by ensuring that materials and components arrive just in time for production, reducing storage costs and risk of obsolescence. 3. Continuous flow. JIT encourages smooth, continuous flow in the production process, avoiding bottlenecks and ensuring that each stage of Production is synchronized. 4. Supplier relationships. JIT relies on close, reliable relationships with suppliers to ensure that materials arrive exactly when needed in the correct quantity and quality. Benefits of JIT. Reduces waste by eliminating excess inventory. Lowers storage costs and reduces the risk of obsolescence. Increases production efficiency and flexibility. Conclusion. Both Kazin and JIT are fundamental to achieving operational excellence in TQM. Kazin fosters a culture of continuous, incremental improvement, while JIT optimizes the production process by minimizing waste and ensuring efficiency. Together, they help organizations improve product quality, reduce costs, and maintain flexibility, contributing to overall business success and sustainability in a competitive market.